Let's sort out and explain the descent planning once and for all. This video is more specific to medium range jet transport and Boeing 737 specific to NG and Maxes. Descent planning is a part of flight where descent starts from top of descent to touchdown on the runway. Okay, planning for it is required even before the top of descent starts, because as good pilots, even if we have all the frills of ND, flight computers, VNAV page telling us where the top of descent will be, but good pilots will always have an estimate of when to start the descent and how to do it even without all those frills. So let's go ahead with it. First, the formula. Memorize the table of 3 till 40. Why? Because Airbus 320 has a service ceiling of flight level 390 and 737 has a service ceiling of 410. Track miles required is whatever your altitude at top of descent is multiplied by 3. Tailwinds, average it out from your cruise altitude till touchdown and then add 1 nautical mile per 7 knots of tailwind. Okay. Speed reduction, whatever your speed at top of descent is, okay, from that to intercept heading what your speed will be. Let's say you start your descent at 280 and you are reducing your speed to 180 knots, it is 100 knots. That means you will need 10 nautical miles of speed reduction. Bonus tip, just stand by for that. Okay, let's take an example and prove whatever we have discussed above is true. Okay, flight level 310, altitude into 3 is 93. Tailwinds, let's assume the tailwinds as nil, so we take it as 0. And speed reduction, let's take it 10 knots because we are descending at 280 knots. There's a reason why we are descending at 280 knots. I'll show it to you just now in just a moment. To 180 knots, that is intercept heading. So if you add all of this, you will get 103 nautical miles. Similarly, if you do it for flight level 410, it will be 133 nautical. Let's check it. Okay, this is a flight and performance manual of given by Boeing en route all engine. Okay, 737. Now in this, if you see the descent is starting at 280 knots and reduction to 250 knots by 10,000 feet. Now for flight level 410, estimating the gross weight as 60 tons is given as 133 nautical miles, and we had calculated 133. For flight level 310, we require 105 track miles as per the manual, and we had calculated 103. So more or less the same. Okay. For more accurate track miles, here is the bonus tip. Add 1 nautical mile for plus minus 1 ton from 60 ton landing weight. Let's see. Okay, let's say our gross weight for landing is 70 tons. Okay. So if we initiate a descent at flight level 310, our track miles required will be 113. Let's see over here, flight level 310, we had calculated 103 and 70 tons cross weight, that becomes 10 miles extra, that becomes 113 nautical miles. Now some important cues during descent. Okay, keep calculating the track miles every 5,000 feet from the time you start your descent. This is important because there will be changes in winds, so keep track of the winds. Use your map mode to anticipate the track miles. This is an important one. Okay, let's say your aircraft is over here and this is your runway and you plan to land over there and you're expecting a vectoring either from this side or from this side. Okay, we are anticipating both ways. So how I'll be calculating my descent will be, if he gives me a direct routing right from here, I'll go 10 miles from here because this is 10 and plus 7, so 17 nautical, approximately 17 nautical miles. And if he's not giving me any direct, I will proceed ahead around 6 miles and I'm expecting a left turn 8 miles and then 7 miles. So this becomes 6 plus 8 plus 6, around 20 nautical miles. So I'm prepared that if he's giving me a shortcut, I would be going 16 miles to touchdown. And if he doesn't give me a shortcut, I'll have 20 miles to touchdown. I'll adjust my descent accordingly. Okay, you can also adjust your descent for a 3-degree descent path using the point number 3, that is ground speed into 5 is going to be, a tricky or a complicated calculation. So what we do is take the ground speed, let's say it is 2580, just put it to half. There 2600 approximately divided by 2, it becomes 1300 feet per minute approximately. So just multiply it by 10 and then divide it by 2. Let's cross check our descent by one more method. On your flight management computer CDU, you have a VNAV descent page. If you go to that page, on the right hand side, you will see a waypoint name, the altitude and the VS. What it means is that to reach the waypoint Mackie at altitude of 6,000 feet, you require a VS of 2360 feet per minute. Now, if you refer to a flight crew training manual, it shows your rate of descent at idle thrust. That is at 280 knots idle thrust in clean configuration, you will get 2200 feet per minute. Similarly, for 737 MAX 280 knots, you will get 2000 feet per minute. Keeping these values in mind, you will be able to identify which pitch mode to use for your descent. And with the help of that, you will be able to maintain idle thrust descent and save more fuel and get more brownie points from your company. Hope you liked the video. Let me know in comments if there is any queries and follow for more. Thank you very much.